To be comfortable with TypeScript. So in this section, I'm going to introduce you to the fundamentals of TypeScript and object-oriented programming principles. So by the end of this section, you will have a good understanding of type annotations, arrow functions, interfaces, classes, constructors, access modifiers, properties, and modules. If you're familiar with these concepts and know how to implement them in TypeScript, feel free to skip this section and move on to Angular. Otherwise, you really need to watch every lecture in this section. So now let's get started. So what is TypeScript? TypeScript is not an entirely new language. It's a superset of JavaScript. So that means any valid JavaScript code is also valid TypeScript code. But TypeScript has additional features that do not exist in the current version of JavaScript supported by most browsers out there. For example, in TypeScript, we have this concept of strong or static typing. If you have worked with languages like C# and Java, you know that in these languages, when we define a variable, we need to specify the type of that variable. Now in TypeScript, typing is optional, so we don't have to use this feature. But using this feature makes our applications more predictable, and it also makes it easier to debug them when something goes wrong. TypeScript also brings quite a few object-oriented features that we have missed in JavaScript for a long time. We have the concept of classes, interfaces, constructors, access modifiers like public and private, fields, properties, generics, and so on. You're going to learn about this in this section. Now, another benefit of using TypeScript is that with TypeScript, we can catch errors at compile time instead of at runtime. Well, of course, not all kinds of errors, but a lot of errors. So there is a compilation step involved, and when we compile our TypeScript code, we can catch these errors and fix them before deploying our application. And finally, another benefit of using TypeScript is that we get access to some great tools out there. One thing that I personally love about TypeScript is the IntelliSense that we get in our code editors. Again, you're going to see that in this section. So TypeScript is a beautiful language, and it's basically a superset of JavaScript. So any valid JavaScript code is also valid TypeScript code. Now, the browsers out there, they don't understand TypeScript. And it's very unlikely that they're going to support it in the future. So we need to compile, or more accurately, transpile our TypeScript code into JavaScript. So this is part of building our application. Whenever we build our application, TypeScript compiler kicks in, and it transpiles our TypeScript code into JavaScript code that browsers can understand. Now that's enough introduction. Next, I'm going to show you how to install TypeScript and write your first TypeScript program. In this lecture, I'm going to show you how to install TypeScript and write your first TypeScript program. So here we're in the terminal. We're not going to work with Angular in this section. We're going to purely focus on TypeScript. So first, we need to install TypeScript globally on our machine. So npm install -g, which stands for global, TypeScript. And of course, if you're on Mac, you need to put sudo at the front. All right, beautiful. So I've installed the latest version of TypeScript, which is currently version 2.3.4. Now we can type tsc, which stands for TypeScript compiler --version. Again, you can see that I'm running TypeScript 2.3.4. All right, now I'm going to create a new folder for this section. So let's call this ts hello. Let's go to this folder. Now here I'm going to create a new file and open it with VS Code. So code main.ts. So now I'm going to write some plain JavaScript code. And I want to show you that all this JavaScript code is also valid TypeScript code. So first I'm going to define a function. Let's call this log. That takes a message. And here we simply log that message on the console, like this. Then I'm going to declare a global variable. Let's call this message and set it to this string, hello world. And finally call our log function, message. So this is just plain JavaScript code, right? Now save. Back in the terminal, we need to transpile this TypeScript file into JavaScript. So tsc or TypeScript compiler main.ts. Now, if you look at the files in this folder, look, we have main.js and main.ts. Now, this transpilation or compilation step, when you're building an Angular app, happens under the hood. So you don't have to manually call the TypeScript compiler. In fact, when you run your application using ng-serve, Angular CLI calls TypeScript compiler under the hood to transpile all our TypeScript code. All right, now let's open our main.js file. So code main.js. So it's exactly the same code that we wrote, but now it's in a JavaScript file. So all JavaScript code is also valid TypeScript code. Now back in the terminal, I can execute this code using node. So node main.js. And we got the hello world message on the console. So from the next lecture, we're going to look at specific features of TypeScript that we don't currently have in JavaScript. All right, let's explore TypeScript by looking at variable declarations. So in TypeScript, there are two ways to declare a variable. We can use the var keyword, which you have seen in JavaScript, like var number, we set it to 1. Or we can use the let keyword. So let count to be 2. Now, before I explain the difference, I need to clarify that the let keyword is also being added to the JavaScript. So JavaScript has a few different versions. We have ES5 or ECMAScript 5, which is the version of JavaScript supported by pretty much all browsers out there. It's been around for a long time. Now we have ES6, which is a newer version, and it was introduced in year 2015. And from that point, the ECMAScript team, which is the team extending JavaScript, decided to use the year number instead of the version number. So we have ECMAScript 2015, 2016, and 2017. Now in ECMAScript 2015, which is basically ES6, we also have this let keyword. But in case you're not familiar with it, let me explain how it works. So I'm going to define a function. Let's call it do something. It doesn't really matter. Now here I'm going to define a for block. So var, we set I to 0. And as long as I is less than 5, let's increment it. Here we have a block and then log it on the console. Now finally, at the end of this function, I'm going to log this I one more time, but with the label finally. And then I'm going to call this function here. So in the terminal, I'm going to compile this file, main.ts, and also at the same time, run it with node, main.js. Note that the value of I at the end is 5. So this is the issue we have when declaring a variable using the var keyword. So we have declared I here inside this for block, but it's also meaningful and available outside the for block. Now, if you have worked with languages like C# or Java, you know that we don't have this concept in those languages. In JavaScript, a variable declared with a var keyword is scoped to the nearest function. So in this case, the nearest function is do something. So once we declare I inside this for block, it's available anywhere in this function. Now let's see what happens when we declare this variable using the let keyword. So let. Now look, we immediately got a red underline here, which indicates a compilation error. And this is one of the beauties of TypeScript. When you're writing TypeScript code, you can catch these errors at compile time before you run your application, before you deploy it. Now let's hover our mouse here. So this is the error, cannot find name I. So now I is scoped to the nearest block instead of nearest function. And this is the proper way to declare variables, which prevents a lot of issues later down the road. Now I want to clarify something. Let me save this file. Back in the terminal, first I'm going to remove main.js. Now I'm going to recompile our main.ts. Okay, we got our error here, cannot find name I. However, if you look at the files in this folder, we do have main.js. So even though we have a compilation error, the TypeScript compiler still generated main.js. Let's have a look at the content of this file. So this is the code that is generated. So by default, TypeScript compiler compiles our TypeScript code to ES5 or ECMAScript 5, which is the older version of JavaScript that is supported by all browsers out there. Now there we don't have the let keyword. So that's why our compiled code now uses the var keyword. And this is perfectly valid JavaScript code. So I can go in the terminal and simply run this code and get the same output as before. So what I want to clarify here is that TypeScript compiler reports these errors, but still generates valid JavaScript code. So here's the takeaway for this lecture. From now on, anywhere we want to declare a variable, we use the let keyword. Once again, this does not stop the compilation step, but at least we can catch the issues earlier during the compile time. Next, we're going to look at different types we have in TypeScript. In this lecture, I'm going to show you different types we have in TypeScript. So let me start by declaring a variable called count and set it to 5. Now, if I set this to, let's say, a character or a string like A, note that I immediately get a compilation error here telling me that this A string or A character is not assignable to type number. Now, we can perfectly do this in JavaScript because in JavaScript, we can change the type of variables on the fly, but in TypeScript, we get a compilation error. Now, once again, I want to clarify that we can perfectly compile this using TypeScript compiler and we will get valid JavaScript code. So if I go to terminal and type TypeScript compiler main.ts, now look, this is our main.js. So we have this count variable and we have changed its value. We can perfectly execute this, no problem. However, code like this is very likely that it's going to break at some point in the future because chances are we're going to use this count variable inside a for block. So our program is going to break at runtime. We don't want this to happen, right? That's one of the reasons it's better to write the same code in TypeScript so at least we can get a warning during the compilation step. Now, if you hover your mouse over this count variable, look at the tooltip. You can see a colon and number after this count. So this indicates the type of count variable in our program. So here, TypeScript compiler inferred that the type of this variable should be a number because we set it to number 5. Now, what if I declare a variable without initializing it? Let's look at its type. Its type is now any. And that's exactly like the variables we declare in JavaScript. So I can set A to 1. Then I can change the value to true and then set it to a string. Even TypeScript doesn't complain about this. So what's the solution? If we don't know the value of a variable ahead of time, that's when we use type annotations. So here we add colon, and after that we set the type of this variable, like number. And then look, on the 3rd and 4th lines, we got compilation errors. Now in TypeScript, we have a few different types. So we have number, which can include any integer or floating point numbers. We have booleans, which can be true or false. We have strings. We have any that you saw earlier. We have arrays. So let's say we want to declare an array of numbers. We would use a number with square brackets. Now we can optionally initialize this to an array like this. Or we can declare an any array, and with this, we can set this to an array with these values: 1, true, A, and false. Of course, it's not a good practice. We want to avoid this, but I'm telling you what is possible with TypeScript. Now we also have another type that I absolutely love, and that's enum. So let's say we are working with a group of related constants, like colors. So in plain old or vanilla JavaScript, we would define constant colors like this. So color red, we can set this to 0. Constant color green, we set this to 1. And constant color blue, set it to 2. Now this is a little bit verbose. In a lot of object-oriented languages, we have this concept called enum. So we can put all these related constants in a container. So in TypeScript, we can declare an enum like this. Enum, all lowercase. We give it a name like color. Now curly braces, and here we set the values. So red, green, and blue. Then we can declare a variable like background color. and set it to color dot. Now look, we have IntelliSense here. So this tooltip you see here allows us to complete this code without remembering all the details. And this is one of the things I love about TypeScript. So let's set the background color to color.red. Now in terms of the values, the first element here automatically gets the value of 0. And each subsequent element gets an incremented value. So we don't have to explicitly set these. But as a best practice, it's better to do so because chances are sometime in the future, someone may come here and add a new color here like purple. And then purple would automatically become 2 and the value of blue would change to 3. So this may break parts of our application. So let me revert this by explicitly setting the values. If somebody adds a new color here like purple, then it will not change the value of blue. Now let me show you something. Let's compile this code and see how we get enum in JavaScript. So TypeScript compiler main.ts. Look at this piece of code here. This is how we can implement the concept of enums in JavaScript. You can see it's very complicated. Now compare this with how we declared an enum here. It's much cleaner. So the more you work with TypeScript, the more you're going to love this language. In this lecture, I'm going to show you the concept of type assertions in TypeScript. So I'm going to start by declaring a variable like message and setting it to a string. Now here we can type message dot, and look, we get this beautiful IntelliSense. And in this tooltip, we can see all the things we can do with a string. So all these items with these purple icons are functions. For example, we have this function called ends with. We can call this and see if this message ends, let's say with C. And this returns a Boolean. So we can store the result in another variable like ends with C. However, sometimes TypeScript may be a little bit confused about the type of a variable. For example, I'm going to remove this initialization here and initialize this variable on the second line, ABC. Now look at the type of this message variable. It's any, because by default, when we don't set a value, the type is any. Now the problem here is that if I delete this and type period, look, we don't get that IntelliSense anymore. Because ends with is something that we can do with a string, not with an object of type any. So what should we do? In this case, we need to explicitly tell TypeScript compiler that this message variable is actually a string. And this is what we call type assertions. Now, how do we do type assertions? There are two ways. One way is to prefix this variable with angle brackets. And here we put the type, like string. Now we need to enclose both these parts in parentheses, like this. Then, if we press period, we get our beautiful IntelliSense with all the functions or methods available on string objects. Now there is also another way to do type assertion. So let's change the name of this variable to alternative way. And here, instead of angle brackets, we use message as string. They're exactly the same. The approach you choose is purely your personal preference. But the first approach is what you see more in a lot of tutorials and code bases out there. Now, I just want to clarify something here. This type assertion does not change the type of this variable at runtime. In fact, it's not going to restructure that object in memory. It's purely a way to tell TypeScript compiler about the type of a variable, so we can access the IntelliSense. Another concept you need to know when using TypeScript to build Angular applications is the concept of arrow functions. So in JavaScript, we can declare a function like this. Let log, we set this to a function. This function takes a message object and simply logs it on the console, like this. Now in TypeScript, there is a shorter way to define this function. So let's call the other one doLog. Now we don't need the function keyword anymore. We can simply add the parameters, in this case message. Then we add this arrow, and that's why we call this an arrow function. And finally, the code block. So console.log message. Now, if our function has only one line, we can even exclude these curly braces. So we can make this code a little bit shorter and cleaner, like this. If you have worked with C#, you have seen this before. In C#, we call this a lambda expression. In TypeScript, we call it an arrow function. It's exactly the same thing. Now, if you have one parameter here, you can even exclude the parentheses. But I personally don't like this because I think it makes the code a little bit less readable. So I always like to put my parentheses here to indicate to the reader of this code that these are the parameters. Now, what if we don't have any parameters? We just add empty parentheses. And of course here, we don't have the message. So if you have not seen this before, get used to it. It's a really nice and clean way to define functions. All right, now let's see how we can use custom types in TypeScript. So I'm going to start by declaring a function like drawPoint. So this function takes an X and a Y and simply draws it on the screen. Now, we don't want to worry about the actual drawing algorithm. We just want to focus on the signature of this function. Now, this function is not too bad. Here we have only 2 parameters. But sometimes when working with more complex concepts, we may end up with a function that has so many parameters, like this. This is really, really bad, and it's something you should avoid at all times. In those situations, it's very likely that a group of these parameters, maybe all of them, belong to a single concept. As an example, think of a car. A car has so many different properties. We don't want to pass all those properties to a function like drive car. Instead, we want to encapsulate them inside an object and only pass that one object here. So in this example, instead of passing X and Y here, it's better to pass a point object. And then we can call this function like this, drawPoint. We give it an object with 2 properties, X and Y. So now our function has a cleaner syntax. However, there is a problem with this implementation. Instead of a point object, I can pass a person object that has a name property. And nowhere here, we are getting a compile time error. But we know that this code is going to break at runtime because the algorithm in our drawPoint function is expecting X and Y properties. So what's the solution? Well, let me revert this back. Okay, we've got X and Y. So there are 2 solutions to solve this problem. One way is to use what we call inline annotation. So just like we can annotate this parameter with a type, like number, we can annotate it with a custom type or a custom object. So here we add curly braces to indicate an object. This object is going to have a property called X, which is a number, and also another property called Y, which is again a number. So this is what we call inline annotation. It works fine for simple cases, but the problem with this, as you can see, is that this is a little bit verbose. Also, chances are somewhere else we might have another function that expects a point object. We don't want to repeat this object literal in multiple places. So in those cases, a better approach is to use an interface. If you have worked with object-oriented programming languages like C# and Java, you know the concept of interfaces. We have the same concept in TypeScript. Now, if you have never worked with interfaces, let me show you how they work. So on the top, I define an interface. And I'm going to call this point. Curly braces. Then I add X is a number and Y is a number. So with this interface, I'm defining the shape of an object. And then I can simplify this declaration and set the type of this parameter to point. This is much cleaner, and we can also reuse this in multiple places. Just one thing, note the naming convention I have used here. So because I'm introducing a custom type, I've used Pascal naming convention. So the first letter of every word in the name of the interface should be capitalized. So here we have uppercase P, not a lowercase p, okay? So when using interfaces, always use Pascal naming convention. So in the last lecture, we used an interface to define the shape of a point object. But there is a problem with this implementation. In object-oriented programming languages, we have this concept called cohesion, which basically means things that are related should be part of one unit. They should go together. This is what we call cohesion. Now back to this example. On the top, we have used an interface to define the shape of a point object. And below that, we have a standalone function. And this is where we have violated the cohesion principle. So the concept of drawing a point is highly related to the structure of a point. It should not be a separate function. Now, if you're going to build a utility library for working with points, chances are you're going to create another function like getDistance that calculates the distance between 2 points. So point A of type point and point B of type point. And this goes to this code block. Again, we have violated the cohesion principle. We have two functions hanging in the air, separate from the point object. Since these concepts are highly related, they should be part of one unit. In object-oriented languages, we call that unit a class. So a class groups properties and functions that are highly related. Now, in this implementation, unfortunately, we cannot move these two functions inside our interface because interfaces are purely for declarations. They cannot include any implementation. In other words, we cannot have the algorithm for calculating the distance between 2 points or drawing a point inside this interface. What we can do instead is to add a function here, a function declaration. So we're going to have a draw function that takes no parameters and returns void, which means it doesn't return anything. Now, you might be asking, why don't we have this point parameter here? Because if all these members, x, y, and draw are part of one unit, we don't need to pass x and y as parameters to the draw function. This function can directly access these properties, x and y, in the same unit. So we don't need this parameter here. Now in interfaces, as I said, we cannot have implementation. We can only have the signature of a function. So with this interface, we're telling TypeScript compiler that our point objects should have two properties, x and y, and a function called draw. The implementation of that is somewhere else. So what should we do now to apply the cohesion principle here? We need to use a class instead of an interface. So on the top, I'm going to change the type to class. And here I'm going to replace this comma with semicolon. So our point class has 3 members. The first 2 members are what we call fields that we use for storing data. And the third member is a function. Now here in this class, we can have the actual implementation of this draw function. So we can simply define it like this: draw, and then add all that logic for drawing a point. Now similarly, we can have another function, getDistance, that returns the distance between this point and another point, like this. Again, all that logic will end up here. Now with this restructuring, you can see that everything about a point is in one unit, in one class. So we have the coordinate, which includes x and y, and 2 functions, draw and getDistance. Now in object-oriented programming terms, we refer to these members as fields and to these functions as methods. So when a function is part of a class, we call it a method. All right, now with this new implementation, we don't want these 2 functions hanging in the air, so delete. This is a much better structure. Also, we're not going to call draw point like this anymore. So here's our point class. In the next lecture, I'm going to show you how to create an object of this type and call the draw method. All right, so here's our class. Now let's declare a variable of this type. So let point be of type point. And then we can type point dot. Look, we have this beautiful IntelliSense. We have 2 methods, draw and getDistance, and 2 fields, x and y. Now in TypeScript, we also have a concept called property, which is different from a field, but a lot of people use these terms interchangeably. Later in this section, you're going to learn the difference between fields and properties. Now, if you want to call the draw method, we simply call it like this. So this draw method is now part of the concept of a point. It's not a function hanging in the air, polluting the global namespace. Now for this demo, I'm going to add a simple console.log here and display the coordinate of this point. So x, now here I want to add the x field, but we cannot use it like this. We need to prefix it with this dot. So that refers to this field in this class. And then I'm going to add y is, once again, this dot y. Now let's compile and run this program and see what happens. So tsc, what should we type here? Main.ts. And we can shortcut by adding this pipe here, type node, and then main.js, okay? We got a runtime error. Cannot read property draw of undefined. So this is the problem. When we call this draw method, this point object was undefined. Because here, unlike the basic types we have in TypeScript, like numbers, strings, booleans, we're dealing with a custom type. When defining an object of a custom type, we need to explicitly allocate memory to it. How do we do that? Well, here where we declare the point object or the point variable, we initialize it using the new operator. So this object is a new point. And here we add parentheses. This is the syntax. Now you can see that we have repeated this point here twice. So we can make this code a little bit cleaner by removing this type annotation. Because TypeScript compiler can infer from this assignment here that the type of this object is a point object. And let's verify that. So look, you're working with a point object. Now, one more time, save. So back in the terminal, TypeScript compiler, main.ts, and then node main.js. Okay, we didn't get an error, but you can see that these x and y fields don't have a value because by default, they are undefined. So we can get back here and set point.x to, let's say 1, and point.y to 2. Now back in the terminal, TypeScript compiler, main.ts. I actually made a mistake earlier. So instead of this pipe operator, we need to use double ampersand on Mac. I don't know the Windows equivalent. So with this, we can combine multiple commands. So node main.js. All right, beautiful. X is 1 and y is 2. So this is how we use the classes that we define in our programs. Now I want to highlight something here. This point here is a class, but this point here is an object. An object is an instance of a class. As a metaphor, think of the concept of a human. Human could be a class, but when we create instances of this class, like John, Bob, Mary, these are all objects. So that's the difference between a class and an object. Next, we're going to look at constructors. All right, so I've simplified the code from the last lecture. I simply removed the method getDistance because we're not going to use it later in this section. So here on the top, we define a point class, and then below that, we initialize a point object. Now, this code is a little bit verbose because we have 3 lines to create a point object and put it in a valid state. What if this point object had a few other properties that we had to initialize like this? And maybe a few more here. Is there a cleaner way? Absolutely. So let me delete this first. All right. In object-oriented programming languages, we have this concept called constructor. So every class can have a constructor, which is basically a method that is called when we create an instance of that class. So let me show you how it works. In the class, I'm going to add a method. The name of this method is constructor. This is a reserved keyword in TypeScript. Now this method can have parameters. So x, which is a number, and y, which is also a number. And then here in this method, we can initialize these fields. So what should we write here? This dot x, we set it to this x argument that we get here. And similarly, this.y, we set it to y. Now look, we got a compilation error here. Because when creating a new point object, we need to supply these values. Look at the error. Supplied parameters do not match any signature of call target. So here, we need to supply the values for x and y, 1 and 2. And with this, we can simplify this code and get rid of these 2 extra lines. And here's the end result. Now, what if somewhere else in our program, we don't know the initial coordinate of a point? In other words, what if I want to create a point object without setting these values? Is that possible? Yes, absolutely. But it's a little bit different from how you have seen that in other languages like C# and Java. In C#, we can have multiple constructors. In TypeScript, we can't. So the solution for this is to make these parameters optional. So here, after x, I add a question mark, and that makes x optional. And similarly, y should be optional as well. Because once you make a parameter optional, all the other parameters on the right side of that parameter should also be optional. This is a rule by TypeScript and a lot of other program languages. So now look, we don't have a compilation error when creating a point object without initial values. All right, so here I've created a point object with an initial coordinate. Now, what if in our program, you want to have this rule such that when we initialize a point object, we should not be able to change the x or y values. With this implementation, I can always come here and set point.x to a different value. How can we avoid this? Sometimes we need this feature in our programs because it will make them more predictable. It reduces the chance for bugs. So, how should we prevent the coordinate of this point object to change after it's initialized? Well, in object-oriented languages, we have this concept called access modifiers. An access modifier is basically a keyword that we can apply to a member of a class to control its access from the outside. So in TypeScript, we have 3 access modifiers: public, private, and protected. Public and private are the most common. And by default, all members are public. Let me show you what I mean. So here, in our point class, we have 3 members, right? We have 2 fields and 1 method. So when we create a point object and type point dot, look, these are the members of the class. And because they are all public, we can access them here. And that's why we can see them in the IntelliSense. However, I can go here and prefix this field with the private keyword. Now, once we create this point object, if I type point dot, look, x is not in the list. It's not accessible. It's private. So if we try to set point.x to 3, look, we have a compilation error in TypeScript. It says property x is private and only accessible within class point. Now with this technique, I can go here and apply the private keyword on the y field as well. And now, once I initialize a point object, I can no longer change its coordinates. I can only call the draw method. Okay? So this is why we use access modifiers, to control access to certain members of a class from the outside. You can apply these access modifiers on fields, properties, and methods. Now, by default, if you don't set an access modifier, it's assumed to be public. So here, the draw method, as you know, is public. I can also add the public keyword here, but this is redundant. It's just making my code noisy. So you don't really need to add this. It's better to keep your code short and clean and use the private access modifier only when you need to. Next, I'm going to show you one of my favorite features of TypeScript around access modifiers. As you write code with TypeScript, you see constructors that follow a pattern like what you see here. So here we have 2 parameters in our constructor, and we use these 2 parameters to initialize the fields in this class. The code looks a little bit redundant. This.x equals x and this.y equals y. TypeScript has a fantastic feature that helps you achieve the same thing with less code. So here, we can delete these 2 fields here. And in our constructor, we can prefix our parameters with an access modifier. So here I want to have two private fields, X and Y. I can simply prefix these with the private keyword like this. So TypeScript compiler will generate these fields for us. And also, we don't need these ugly, repetitive assignments either. So if we prefix a constructor parameter with an access modifier, whether private or public, TypeScript compiler will generate a field with the exact same name, and it would also initialize that field with the value of this argument. It's one of my favorite features, and you're going to see that a lot in this course. Now, I'll clarify something before I finish this lecture. In this case, our fields were private, but if they were public, we would use the public keyword here. So this means when we create a point object, we can access the X field. Okay? So I'm going to revert this back to the private. All right, now this implementation has a tiny problem. We can set the initial coordinate of this point, and we can also draw it, but there is no way for us to read the coordinate. So I cannot access point.x here to display it to the user. What's the workaround? Well, one simple solution is to define a method like this, get x, and here we simply return this.x. Because in this class, we do have access to all the private members of this class, but we cannot access them from the outside. Okay? Now here, I can always call point.getX to get the x value and display it to the user. Now let's talk about another use case. Maybe we want to give the user the ability to set the initial coordinate here, but we also want them to be able to change this coordinate later only if they provide a value within a given range. What do I mean by that? Let me show you. I'm going to define another method here, set x. Now this method is going to get a value. That's the new value for the x field. Let me scroll down. Now here, first we can do some basic validation. So if value is less than 0, we want to throw an error. Throw new error. Value cannot be less than 0. Otherwise, we want to set this.x to this new value. Okay? Now with this implementation, we can always change the value of the x field like this. Point.setX, we set it to a new value. Now, if you have a use case like that in your applications, you can use what we call a property. So in TypeScript and in a lot of object-oriented programming languages, we have a concept called property, which is exactly for this very use case. So look at how I can define a property here. We start with a keyword, which is get or set, and then the name of the property, which is in this case x. And after that, we're going to have parentheses, just like a method. Okay? Now, similarly, I'm going to change this to set with a space. So we have the set keyword. And here it's like we have a function, a method. Now, what is the difference? The difference is that we can use these properties like fields. So here, I can read x like this. Dot. Note the icon of x. It's the same icon we have for fields. It's not a method anymore. So we can read x. And we can also set it like this. Point.x, we set it to 10. We don't have to call a method like this. It's a cleaner syntax, okay? So this is what properties are for. If you have private fields that you want to give maybe a read-only access to the outside, or if you want to give the consumer of your classes the ability to set the values, but you want to have some basic validation, that's when you use a property. Now, in this case, if I want to give only the read-only access to this underlying field, I can simply comment out the setter. So we call this method a setter and the other method a getter. Okay? And now look at this compilation error. We cannot change the value of x. Now let's bring this back. One last thing before we finish this lecture. So here I have used a capital X for the name of my x property. In JavaScript and in TypeScript, we use camel notation to name our fields. So that's why Earlier, we defined this private field here using camel casing notation. Camel casing means the first letter of the first word is lowercase, and the first letter of every word after is uppercase. Now, what should we do to use camel casing notation for our properties? If I name this the lowercase x, it clashes with the existing field. So let me revert this back. A convention we use to solve this problem is to prefix the name of the underlying field with an underline. So let's rename this using F2 and prefix it with an underline. Okay. Now similarly for the y parameter or the y field, I'm also going to use underline y. Then we can rename this property from capital X to lowercase x. Once again, we press F2, lowercase x, and note that both instances, both the getter and the setter, are updated. Now, we can work with this x property exactly the same way we use the x field. So here's the lesson. A property looks like a field from the outside, but internally it's really a method in the class. Well, more accurately, it's either one method, which is a getter or a setter, or a combination of a getter and a setter. All right, I've simplified the definition of the point class. I removed the properties. So we have a simple constructor and the draw method, and we're using this point class below its definition. Now, this is a very simple program with only one file, but a real-world application consists of tens or hundreds of files. We don't want to write all the code in one file like main.ts. So ideally, I want to move the definition of this point class somewhere else in a file like point.ts. So here in this project, I'm going to add a new file, point.ts. Now back in main.ts, I'm going to select all this code, cut it, and move it to point.ts. Now, in TypeScript, we have this concept called modules. Now, what a module is requires a little bit more explanation, but for now, let me give you a simple, pragmatic definition. In TypeScript, you can think of each file as a module. So in this program, we can say we have two modules, but this is not quite accurate because these files are not modules yet. So in point.ts, we have defined this class called point, but this is not accessible anywhere outside this file. So this file defines its own scope. In order for us to use this class somewhere else in our program, we need to export this to the outside. So we add the export keyword here, and now this is visible outside this file. Now that we're exporting something on top of this file, from TypeScript's point of view, this file is a module. Now we need to go back to our main.ts and import this class so we can use it. So back in main.ts, look, we have a compilation error. Cannot find name point because we have not imported this into main.ts. So on the top, we write import. In curly braces, we add the name of the types we want to import. In this case, point. Now, if there are multiple types we want to import, we separate them using comma. Okay? So we import point from. Now here we put the name of the module in quotes. What is the name of the module? It's the relative path to that module from this file. So both these files are in the same folder. We can use period slash, which refers to the current folder. And then point is the name of our module. So it's not point.ts. Look, we get a compilation error. So the name of our module is point. Now we no longer have a compilation error here, and we can create an instance of this point class and use it. Now there's a lot more to talk about when it comes to modularity in TypeScript, but that's all you need to know for now in order to start building applications with Angular. Because in Angular framework, we have a lot of types that are exported, so we need to import these into our TypeScript files and use them. You're going to see that a lot in this course. The only difference is that Angular modules are defined in a different way, so we don't add the relative path to these module files, because these files are not really part of our application. They're somewhere inside node_modules folder. So when it comes to importing types defined in Angular, we use the library name as the module name. For example, one of the libraries is @angular/core. Okay, so here's the lesson. In TypeScript, we divide our program into multiple files. In each file, we export one or more types. These types can be classes, functions, simple variables, or objects. And wherever we need to use these types, we need to import them first. When we have an import or export statement on top of a file, that file is a module from TypeScript's point of view. In Angular, we also have the concept of modules, but Angular modules are a little bit different. They're not about organization of code in different files. They are about organization of your application into smaller functional areas. You're going to learn about Angular modules in the next section. Hi, thank you for watching my Angular tutorial. If you enjoyed this video, please like it and share it with others. Also, you can subscribe to my channel for free new videos every week. This video is part of my complete Angular course with almost 30 hours of high quality content where you will learn everything about Angular from the basic to the advanced topics all in one course, so you don't have to jump from one tutorial to another. In case you're interested, you can get this course with a big discount using the link in the video description. And if not, that's perfectly fine. Continue